Starting, I want to confirm how was your examination, my dear friends. The question was very good. The question was very good, and even you can see the different questions which have been asked by the CBSE into the examination was very much easy, though the question was little lengthier. But yes, it was very all the questions were easy and conceptual. Okay, so your preparations were definitely good, and all of you have given the best examinations, I know, and you will always score good marks. Okay, so with this, let us start the next paper. For the preparation for the next paper, nevertheless, we should not wait for more time. Okay, so the question which I have taken for today is that three bulbs connected in series. Okay, the three bulbs, one bulb is of 25 watt. Okay, three bulbs which are connected in series are, one is 25 watt, one is 25 watt, another is, in the series this connection is happening, so definitely the second bulb is also looking like this, and it is just connected in a single wire. Okay, let us connect the third bulb like this. Okay, one is 25 watt, another is 40 watt, and third bulb is of 60 watt. Okay, all these three bulbs are connected in a series, and here we have a switch. Here we have a switch, and this is given by a power supply source. Over here is a 6 volt of battery, the positive terminal of the battery over here and negative over here, right? And here also an ammeter is fixed just to measure the current, right? You know the device ammeter is used to measure the current, right? Now this is the electric circuit in front of you, my dear friends. Now the question is that, the first part of the question is that when the switch is into the open position, right, whether any of the bulb will glow. My dear friends, when the switch is open, that means the connectivity between the circuit is broken, right? This is broken, right? Switch is open, that means connectivity of the series circuit is broken. And by simple concept, you know that when any wire or the source of supply which is giving the current to the bulb is broken, from here it's open, then definitely this will not glow, this will not glow, this will not glow. Okay, because current will not pass from here to here, because current will start from this battery, it will start moving into this direction, right, positive to negative, right, and it is just reach till the point of A. It will reach till the point of A, let us say a small a, right, but it will not reach the point of a small b. Why? Because this switch is open, right? So the first part of the question is that switch is open, then connectivity is broken, then no bulb will glow. No bulb glow. Now the second part of the question is that 25 watt, 40 watt and 60 watt, three bulbs are given to you. Which one is brighter? So to understand this concept, we need to understand that into the question it's also given that the rating, if the rating of the, what is the rating of the bulb? If you have seen the bulb, on the top of the bulb, on the top of the bulb, when you see, okay, if this is the top view, okay, then it's written that this much of watt, the wattage of the bulb is given, right, and even the voltage is given, maybe 220 volt with a tolerance limit of 10%, but this is not mentioned. But these two data is given to you into the question, right? This is for the upper view of a bulb, which I am showing you. Okay. Now, my dear friends, here you can see we know the concept that when the circuit is connected in parallel, right? When the circuit is connected in parallel, any circuit, when the circuit is connected in parallel, what is the parameter which we are taking? For a parallel circuit, it's voltage, isn't it? For a parallel circuit, it's voltage, right? Because voltage across the different branches are equal, isn't it? Voltage across the different branches are equal. Now, when you just consider here the circuit which is in parallel connection, for a parallel circuit, that means circuit is like this. Maybe something is connected, after this another branch is there, right? After that another branch is there, like this. Okay, so this is a parallel connection, and here the voltage is the constant item which is taken, right? Now, when the circuit is connected into a series connectivity, for a series connectivity, if you remember, we always take the we always take the for a series connectivity like this, right? We always take which thing into common? Tell me. Current is the constant item, and this is taken as a common, right? So for a series connected circuit, the item which is taken as constant is I, current, right? Here it was voltage, and here it's current. Now into our question, coming to the question directly, into our question, it has been asked into the second part of the question, that which of the bulb is brighter? Which bulb is brighter, my dear friends? You can think of. Definitely, you see 60 watt, and the answer coming into your mind that yes, 60 watt is the brighter. But that is wrong. 60 watt is not the brightest of bulb from all the three, right? If you want to understand, then we need to understand that which will have higher resistance, right? Because for a higher resistance, the heat dissipated into that bulb will be higher. Okay, actual power for that bulb will be higher, the brightness of that bulb will be higher, right? So if we have three bulbs for 25, 40 and 60 watt, then as per the rating which I understand to you, and just we explained that what is the reason behind, the power and voltage are the two sources, okay, for the bulb, right? So that's why, though being connected in series, we are not taking this current as a constant item over here, but the constant item over here is 220 watt, right? 220 volt, right? So 220 volt is the rating of all these bulbs: 25 watt, 40 watt and 60 watt. This is the rating. Why rating? That means the companies are manufacturing the bulbs with a standard rating, that whenever you are supplying this bulb or connecting or using this bulb by putting it at your home or any place, then the source of supply should have a rating of 220 volt. Many times when the voltage is dipped, then you can see in your home the bulbs or the equipments trip, okay, or it goes dimmer, the lights goes dimmer, the speed of the fan goes slow, right? So when the voltage fluctuates, it will directly impact the electrical appliances in your home or at your office, at any place, right? So what I want to explain is that voltage is the component which will be taken over here to consider to go for the any calculations into this circuit. Though it is series connected, we are not applying this concept of constant current over here, right? Now coming to the question directly, which one is brighter, which one is brighter, and what is the order of brightness of these three bulbs, 25 watt, 40 watt and 60 watt, which is brighter? So my dear friends, as I explained, we are not going to take current, we are going to take the voltage, because that is the rating of the bulb which is responsible for the brightness of any bulb, right? Now if you see, what is the rate, what is the resistance of these three bulbs, that need to be calculated, right? So first of all, let this 25 watt bulb is having certain resistance, that is R1, and after that we can see, or we can take 40 watt bulb which is having certain resistance, that is R2, and after that take 60 watt bulb which is having certain resistance, and that is R3. Now what is the order of R1 and R2 and R3? This will reflect which bulb will be brighter. Now my dear friends, here you can see, as I say, voltage is taken, right? So 25 watt, so this is the power, this is the power of the bulb, this all these three, right? And this is the resistance, this is the resistance, this is the power. Resistance is R1, R2, R3. Now my dear friends, we know the formula that power is equal to V square divided by R, isn't it? Power equal to V square divided by R. So this formula we are going to use, not I square R. Why? Because I explained just now, right? This concept. Now my dear friends, tell me, if voltage of all the three bulbs, the rated voltage of all the three bulbs is 220 volt, this one, then that means if the voltage for all the three bulbs will be constant, if the voltage is constant, then how R1, R2, R3 will be varying, right? So here we can see that for this we can say that if power equal to V square by R, so from here we can say that R equal to V square by P, isn't it? Isn't the same relation can be written? R equal to V square by P. If R equal to V square by P, then the table which we drawn for the three bulbs will give you the values as R1 as V square by P1, R1 as this R1, let me write R1 as V square by P, R2 as V square by, here it was P1 and here it will be P2. Why P1, P2? This is P1, this is P2, this is P3. That means 25 watt is P1, 40 watt is P2 and 60 watt is P3. Now my dear friends, if R1 is V square by P1 using this formula, then we can say that V square by P1, that means voltage is constant. the common rating of the bulbs to 20 volt. So it will be 220 square divided by P1. What is P1 over here? P1 over here is 25. Right? For the second bulb, bulb, what is R2? R2 is 220 square divided by P2. What is P2? P2 is 40 watt. So it is coming into the denominator. Mind it, use this formula V square by P. Now from here you can see for the third bulb, we have not written it. For the third bulb, this was R2 equal to V square by P2. Similarly, if you take for R3, R3 is equal to V square by P3. P3. And what is P3? P3 is this 60 watt. Right? So this will give you for the third bulb, right? I'm writing it here. P1, P2, P3 as the values of 25 watt, 40 watt and 60 watt. Right? Now from here we can see R3 is V square by P3. What is V square? 220 square. So I'm not going into the calculations, my dear friend. R V square divided by P3. What is P3 over here? P3 is this 60 watt. So just take this over here, 60 watt. So my dear friends, now this is the time to understand 220 square by 25, 220 square by 40, 220 square by 60. 220, these are the three values for R1, R2 and R3, isn't it? These are the three values for R1, R2 and R3. Right, my dear friends? These are the three values. Now, R1, R2, R3 are these three values for these three bulbs. So let me write it over here. R1, R2 and here R3. P1, P2, P3 as the power. R1, R2, R3 are the corresponding resistances for these three bulbs which are connected in series here, this one, right? Now you can see which one will be greater. This value here, the denominator is the smallest and this is the 60 is the biggest number and all are in denominator, so the reverse order will work over here, right? So this will show that this value 220 square by 25 is greater than 220 square by 40 and this will be greater than 220 square by 60 because denominator is least. With a least number we are dividing a number, so this will give a greater value, and here with a bigger number we are dividing the numerator and numerator is common over all the three places. So we can say that this value 220 square by 25 is greater. It's greater than R2. R1 is greater than R2 and here this value will be greater than R3. So we can say this will be the sequence of the bulb, right? This will be the sequence of the resistance of the bulb, right? So from this we can say that if these three bulbs are there, then we can say that R1 is greater than R2 is greater than R3, right? This is the conclusion. R1 greater than R2, R2 greater than R3. If this is the scenario which we have proved, right, then this will show that out of the three bulbs which are connected over here, out of the three bulbs which are connected over here, if the sequence we have proved that R1 is greater than R2 is greater than R3, right? If this is the condition, then into this case, which will dissipate higher power, right? Which will dissipate higher power? You can see which will, if you find the resistance of all the three bulbs, if the sequence will be like this, and you can say that the current, the current which will be flowing, right? The current which will be flowing is given by I, right? If I is the measurement of the current, whatever be the value, forget it. If you see the brightness, then you should consider the value I square R, right? So if you consider I square R1, if you consider I square R2, if you consider I square R3, you can see this is greater than I square R1 is greater than I square R2, which is greater than I square R3. And this is so that which will be brighter? I square R1 is the rating of is the power of 25 watt bulb, right? This will dissipate more power, this will dissipate more current, right? Because R1 is greater, this will dissipate more current, and this will glow more brighter because R1 is greater. You know, heat dissipated in a circuit will be higher with a higher resistance, right? So since the sequence R1 is greater than R2 greater than R3, which we proved over here, right? So we can say that this is the, if this is the sequence, then 25 watt bulb is brighter than 40 watt, which is brighter than 60 watt, right? So this will be the sequence, my dear friends, right? This will be the sequence. And our question is that three bulbs connected in series. The question is that three bulbs connected in series, the brightest one. Our answer is the brightest one is the 25 watt bulb. 25 watt bulb is the brightest one, right? Now, here, my dear friends, we see how the three bulbs work, why the concept of series circuit is not applied over here, because the bulb is mentioned with two things, wattage and voltage, right? Only these two things you are able to see on the bulb and on the top view, right? So that's why we use the concept of power equal to V square by R. This will give you the value of, quickly I'm recapping what we discussed today. So R is can be calculated as V square by P, right? So resistance of the three bulbs 25 watt, 40 watt and 60 watt are R1, R2, R3. If we assume it, then the corresponding value of R1 is V square by P1, R2 is V square by P2 and R3 is V square by P3, where P1, P2, P3 is 25 watt, 40 watt and 60 watt. Now if you put up the, you can see the common rating for all the three bulbs 220 volt. It's nothing that you are glowing this bulb at certain voltage, this bulb at certain voltage. If this will change, then our answer will change. Okay, mind it. Now here the value of R1, R2, R3 is calculated. You need not to go into the calculations. You can see this denominator is the lowest one 25 and here 60 is the highest one. So this will give you the value of R1 as the greatest value, R1 is greater than R2 and R2 is greater than R3. This will be the sequence. Now if this is the sequence which I have written over here two times, then the resistance of this bulb will be higher, it will dissipate more power, I square R. If you use the formula I square R, more heat will be generated, more power will be given, more, I mean to say brightness will be there, right? So this will give you the resistance R1 is the resistance of 25 watt bulb, right? So 25 watt bulb is the brightest one among the all three bulbs. One more question which I want to take quickly, question number 2, though this is not meant for this, only one question I have scheduled. But remember, one good question this will come into the examination. Remember the formula from the electric current, that resistance of an electrical wire. If this is a wire given to you whose length is L, right? Then into this R is equal to rho L by A, right? And A is the, if you consider the cross section of the wire, this is A and this is the length, right? You know the basic mensuration, right? Basic concepts. So just apply it over here. Rho is the resistivity of the electric wire, L is the length of the electric wire, A is the cross section of the electric wire. It may be copper, it may be aluminum, it may be gold, iron. No, not gold. Yeah, gold is very much costly. Okay, even it's very difficult to take silver also, right? So anyway, I meant to say on the lighter note, it is a metal. So whatever the formula is there, any of these item will be missing to you, right? Just it is asked into the question. Suppose L is asked and rest of the items is given, resistance, resistivity, and area of cross section is given to you. Then easily calculate L. Or any of these variables will be missing. Then this question can be asked into the question. With this, I am winding up today's session, my dear friends. Take care. Happy learning. Bye bye. Expecting good results for your yesterday examination of mathematics, and all of you have done good, I know. Thank you. For take care. Bye bye. Keep your preparations on the top momentum.